sensors, ranging from torque, force, sound, vibration, weight, and strain gauges. And I would like to share with you some thoughts about new integration of smart sensors into vertical IoT platforms, which is a very strong trend to improve efficiency and connect machinery to the cloud systems. Let me share with you my agenda for today. So I would like to talk to you briefly about IoT platform strategies. What does it mean? What could be done by yourself? What could be done by external service providers? Then bridging to the cyber-physical systems, meaning where's the border from the real world to the IIoT. Thirdly, I would like to share with you some thoughts about cyber-physical systems. And here in particular, cyber-physical production system, we talk about machinery and automation. After that, I would like to share with you some examples about cyber-physical production systems and their implementation and the benefits. And after that, I would dig a little bit deeper into the smart sensor world and talk to you about the smart sensor stack. What does it mean, vertical integration, and what services and functions are needed to do so? And what does it imply for the connected infrastructure? So in this case, for machinery today and tomorrow. Where do we stand today? What benefits we can gain tomorrow? And to share with you some thoughts about that. And finally, I would like to talk to you a bit about the implementation strategy, what benefits it brings. And at the end of my presentation, I would like to summarize what we have been talking about. So let's start. So if we talk about IoT platform strategies, there are different options to do so. It could be that you do everything by yourself, so meaning from the bottom, from the infrastructure, over networking, over storage, server, runtime, middleware, the IoT platform, and also the IIoT applications you can host and write code by yourself. But on the other hand, to the right side, you can also outsource this or partner with external companies. They provide you the infrastructure, the network, storage, server capabilities, and also the IIoT platform, runtime versions, middleware, and operating systems. And finally, they can also provide you your application, your IIoT application to show you and work for you the dashboard and the data analytics you are interested in. So a wide range from the left to the right side, and there are also some opportunities in between, some hybrid solutions where you outsource some parts of your IIoT platform and do the remaining stuff by yourself if you have the capabilities. But this is a case-by-case decision depending on your environment and your capabilities and resources. And there are places and applications for each of those four architectures and structures, depending on who you are, what you want to achieve, and what resources do you have. And this is also related then, if we talk about the automation pyramid or the pyramid in manufacturing. So if we go and look from the bottom side, the signals where they are created from sensors or vision systems, and where the motion and machines and actuators are driven, that is the lowest level. This is usually connected to the PLC system, which then is closely linked to the SCADA and the HMI system. And this HMI and SCADA system is closely connected to the manufacturing execution system, which is then controlled by the ERP, the Enterprise Resource Planning System. So a classical architecture found in many companies, many structures, and still the common approach to build this flow. And if we now connect and link this to modern IoT platforms, and this is just an example coming from the Siemens world. This is the MindSphere architecture, so it's quite similar to the left-hand side, coming from the field device, looking for sensors, motors, and drives, working with controllers, have the edge computing, have the MES system, connect to the cloud, and on top of that, the applications for your use case. These are all part of this IoT structure and platform system. And that is very much important if you then talk talk about requirements about the field devices, the sensors, the motors, the drives. What should they provide? How deep should they be integrated, not only technically, but also business-wise into the customer's world? So meaning going above the controller and the edge computing level, maybe go into the machine execution and manufacturing execution and into the cloud and directly connected to the apps of the user. What does it mean actually? So if we talk about the physical world where the sensors and actuators are connected, that is classically the physical part of the machinery. And on the other hand, we have the cyber part, if you remember the higher levels in the pyramid, that are the network, there's the control, the information, and also the modeling of several physical properties and processes. And what you can imagine is in between there we have the sensors, and nowadays the smart sensors, the interfaces, the actors, the motion controllers, and the drives. And that is quite important because the physical part is exchanging information via the smart sensors with the cyber part, and also the physical part is controlled via the actuators from the cyber part into the physical world. And that could be not only two as shown here, it could be many. And smart sensors play here really an important role in the connection between the cyber part and the physical world. And I would like to give you an example to make it a little bit tangible. So here, this is a classical office chair. And I have the idea to make a smart chair out of it so that I can see if somebody in another room is sitting on the chair, but not only if somebody's sitting on the chair, but also who maybe sits on that chair without going to that room and check physically who is sitting on that chair. So actually, what does it mean to make a smart chair out of this standard chair? First of all, it has to have an identity, a unique identifier, how I can address this chair. So I don't want to see any chair which is occupied. I want to see exactly this chair, therefore I need an identity. Then I have to have a connection from the chair to me or to the outside world. That could be wireless, that could be wired. That doesn't matter, but there has to be a channel from the chair into the outside world and backwards. And finally, to determine if somebody's sitting on the chair or who might be sitting on the chair, I need sensors. That could be a weight sensor to determine the person's mass and the weight who is sitting on the chair, but it could also be vibration sensors, how the person is moving with the chair. That could be sound sensors. That could also be temperature sensors. So the whole bunch of sensors, sensing elements I can equip with the chair to see and to try to analyze who might be sitting on my chair. And finally, I need the data processing around the sensors so that I can process the data and build some models saying a person of this weight and with that vibration and with that temperature might be a person of a height of 1.80 meters. And then depending on the weight and the behavior of the chair, I might have a model that's saying it's my colleague A or B sitting on that chair in the neighbor room. And if I then transfer this idea to the reality, to come back to the real world, and that is already existing, this kind of cyber-physical stuff and smart solutions. So you have may heard about smart home or smart home control, where this is already reality. In the traffic world or in the smart city world, that depending on the behavior of the different participants, the system is optimizing itself. In the energy world, we talk about smart grid to connect energy consumption and energy generation in an optimal way, that you have really a good yield and outcome of the grid, of the energy generation, and also for the consumers of the energy. And finally, this is also the case for production environment in the automation world. There we already have smart sensors and data processing in a connected factory to optimize the production processes. So, and if we talk about production and automation processes, so it's nothing where end users are involved. So it's then called a cyber-physical production system. So this is a subset of the classical cyber-physical systems, so-called CPPS, cyber-physical production systems. And here I have some examples how these cyber-physical production systems could look like. So from the first view, it looks like a standard machinery. But if you look a little bit deeper, and that is on the left bottom corner, you see there's a sensing element. In this case, it's a torque transducer, a rotary torque transducer, providing digital data to the control system about the status and the information of the powertrain, which is here tested, then provided to the PLC and SCADA system, and finally visualize and display the data in a dashboard. Another example here where we talk about yield and yield optimization. This is a filling machine. It's a milk filling machine, a carousel. And with very valuable liquids like soya oil, some kind of milk or ketchup, it's very important to have the right weight in the bottle, not to overfill, not to underfill. And that could be done also with a smart sensor, with the smart load cell, which you can see here on the bottom below the bottles. And this digital smart load cell controls the coarse feed, the fine feed, and controls the machine with optimized algorithm and modeling. And that is the key. So if you want to integrate digital and smart sensors vertically into the IoT architecture, you need first of all a digital connection that you are able to go from the sensor actor level with the communication path into the cloud, into the application space. That could be here, as seen, there are some HBK transducers who used to have that, digital load cells, digital torque transducers, but also many others, which are already in the portfolio, have the capability to do so. Yeah, that means actually that the CPPS, Cyber Physical Production Systems, integrate vertically with smart sensors, because the smart sensors or the Cyber Physical Production System acquires data via the integrated sensors and digital instrument in real time, as you have seen from the example with the filling. So it's really needed a real-time analysis, not a post-process analysis. It has to be a closed loop to control and work with the machine. But in addition to that, smart sensors also help to store and analyze data for the modeling purposes. So meaning self-adapting models who optimize themselves as many or more processes are done. So this also will help to optimize the machinery. And finally, the smart sensors in the cyber physical production systems operate actively with actuators, human and digital interfaces via communication interfaces and the internet services which can be provided. And that brings me to the basic architecture of the smart sensor stack. So if we talk classical sensors, we talk about sensor hardware and an external AD converter, maybe in the cabinet, maybe close to the sensor, somewhere in the cable. But with the smart sensors, there's already the digital logic unit incorporated in the sensor, so that the data processing can be done as close to the sensor. And secondly, due to the reason that it's really one connected device, the sensor logic unit is optimal, synchronized and adapted to the sensor hardware. That means with the integrated sensor logic unit and the sensor hardware, you can get better and more reliable data and sensor results than with two external units, with the classical hardware from a sensor and an AD converter or signal conditioning device with cables in between. So if you merge this together, this has actually already a huge benefit to the data quality. But that's not all. If we talk about the interface unit, so that is the example I had with my smart chair. So that is really a key factor, that we have an interface unit from our digital sensor to the automation pyramid or to the IoT platform. That could be different things. That could be wired, that could be wireless, that could be traditional interfaces, that could be new interfaces, that could be real-time interfaces with high data rates, that could be interfaces with lower data rates when they just transmit events or triggers and results. And finally, if I want to really utilize the full capability of smart sensors, then I have to talk about the so-called service unit, which is then connecting seamlessly to the cloud architecture in your environment, meaning what the cloud architecture provides, like user management, diagnostics, dashboards, update of features or extension of features of the sensor via the cloud architecture. These are services which can provide additional value to the machine operator and really helps him to get more output and more yield out of the machinery. Yeah, and these are again the 4 basic blocks of smart sensors. So the logic unit, that could be simply data processing, so meaning giving out a weight or a force to the interface and then to the control system or to the IoT structure. But it could also be decentralized logic, meaning like a filling algorithm, just saying the bottle is now empty and then now it's full, and that is the status, and this is provided. And everything else, the logic is done in the operating unit, in the logic unit. But that could be also other artificial intelligence functions or machine learning to optimize machinery and to get a faster run of the machine and a higher yield and a better output. As said, the interface is an inherent part of a smart and digital sensor because the smart sensor has to connect and communicate with the outside world. There will be not only one interface, especially when we talk about IT sensors, where we really closely and easily connect directly to the IT world, so without edge devices. So there will be opening new interfaces like TSN or others or other wireless technologies to capture this trend and be there more and better integrated. And yeah, the service unit, this is really providing additional value to the user because the service units, whatever you offer, like maintenance, functionality maintenance services, diagnostic services, user management, some other messaging services, because these then could directly connect to the dashboards of the user. I call it here DB unit 1, 2, 3 or N. So because the services then really provide and closely link to the useful data the user of the machine wants to really see. And what is the purpose of all that vertical integration? Because today machinery is not fully used and utilized, but there's also some motion which is not really bringing productivity in the machinery because the utilized motion is lower than the real possible motion. Also in the cycle time area, there are some gaps, which allow us also to look where we have unused cycle time. And finally, we talk about troubleshooting and standstill. This is a big issue to prevent this, to have a 24/7 operating of the machinery. And with the industrial Internet of Things and the smart sensors, the operators could be capable to optimize the machine capacity. That really there is no idle movement in the machinery, that we cut the unutilized cycle time by self-adapting and negotiation mechanisms to facilitate the capacity. And thirdly, to look for predictive maintenance to prevent any ad hoc standstills, but also these intervals with fixed maintenance. So the predictive maintenance to look for case-based maintenance will be a big issue and improve efficiency a lot. But how to do so, how to accelerate this development, and there's really something what we have seen also in the examples. So from this pure centralized decision making in a PLC, in a control system, we have to go to decentralized decision making. And that could be done by using and orchestrating all the existing tools and solutions we have right now to disclose migration paths and to show a way how this can be achieved. Yeah, what does it actually mean? If I have here an analogy as an example, if you talk about classical intersection, many lanes, the classical approach would be to use your traffic lights, a centralized control system is controlling the traffic lights, and maybe also self-adapting to have an optimal traffic flow. But if we talk about decentralized, then we can talk about this roundabout where there's no centralized traffic light or control system, because each participant here, each driver, is responsible for his decentralized decision and therefore optimize the traffic flow in this roundabout. So this is the analogy also to the smart sensors in machinery. So we will have decentralized, intelligent smart sensors, which have logic functions, interface capability, and provide services to ensure these smooth way of operation also in machinery. So what does it mean actually? The smart sensors and digital instruments will go more and more into end user products, what we have already seen in the smart home or any other consumer product, into test systems in production machinery, because we have to facilitate the development of new models and decentralized decision making. And respectively, we would also look for holistic modeling and vertical integration. So each participant can contribute with his intelligence and with his decision making to an optimized overall decision if it's vertically optimal integrated. So to be clear, decentralized modeling will be an inherent part of the IoT architecture. If you remember the pyramid or the mind sphere architecture, so a lot of modeling and intelligence will be moved from the middle and upper level to the lower level into the sensors and motion control devices. But you only can do models and improve your models if you have comprehensive data from the digital sensors and the instruments, and apply self-learning and machine learning algorithm to improve over time by self-adaptation. So to sum it up, so it will be a long journey. It will be a long path down the road. It will be rather a technical evolution instead of a revolution. So there will be no switch from 0 to 1 with IIoT and smart sensors. There's still a networking between humans and machines needed. But one thing is quite clear. Without smart sensors and digital instruments, there will be no dynamic modeling. And what does it mean if we don't have dynamic modeling? We will not use or utilize the IoT benefits. And the smart sensors will help with logic, interfaces, and services to distinguish through value-added services and capabilities to the overall IoT structure. So really from the application, which is used by the user or operator of the machine, down to the smart sensor in the physical world. Yeah, that was it for the time being. Thank you for listening. And now I'm open for questions, and I would like try to give you an answer about your questions. Thank you very much.